machine learning, Internet of Things, and big data. As we gather here, we recognize the transformative power these technologies hold in reshaping industries, economies, and societies around the globe. And as we convene for the fourth time, we are poised to delve even deeper, push boundaries further, and unlock new frontiers of knowledge and opportunity.
Throughout the next few days, our agenda is packed with stimulating keynote speeches, hands on workshops, and presentations of cutting edge researchers. We will hear from trailblazers who are pioneering advancements in machine learning, IoT, and big data analytics. We will explore how these technologies are being harnessed to address real world challenges in healthcare, finance, transportation, agriculture, and beyond.
Before we proceed with the event, I request all the dignitaries to kindly come up on the dais and take their respective seats. I request Professor Dr. AVNL Sarma Sir, Vice Chancellor GIT University Gunupur, Dr. AB Srinivas Rao Sir, Dean School of Engineering and Technology GIT University, Professor Kakita Mulli Gopal Sir, Dean Computational Science, Ms. And Dr. Sibarama Panigrahi Sir, our guest speaker for today, to please take their seats.
Along with that, I would like to call Srinivas Sethi sir to please join us on the stage. We are honored to be joined by some of the brightest minds and influential voices in the fields. Their insights and experience will inspire us and provoke the new ideas and catalyze collaborations that have the potential to shape the future.
The lighting of the lamp symbolizes the dispelling of darkness and illumination of knowledge, wisdom, and auspicious beginnings. Without further ado, let us commence the sacred ritual. I would like to invite our esteemed dignitaries to please come forward and illuminate the lamp as we are accompanied by
So now moving forward, ladies and gentlemen and esteemed colleagues, it is the distinct honor and privilege to extend a warm invitation to none other than the Professor K. Murli Gopal Sir, the esteemed Deputy Dean of Computational Science at GIT University. He is not just a leader in his field, he epitomizes the very notions of perfectionism. With his unwavering dedication to excellence and his unparalleled commitment to advancing the frontiers of the knowledge, beyond his exceptional academic powers, his great attitude and approachable demeanor has engaged his students and colleagues alike. His willingness to share guidance and offer knowledge and nurture talent exemplifies the true spirit of mentorship and leadership. With said, it is with the immense pleasure that I invite Professor K. Kakita Murli Gopal Sir to address our gathering and the audience today. Please, sir. Goes to present the bouquets. With invite gathering. Please, sir.
Good morning, everyone. It's my immense pleasure to be here to invite the delegates, Srinivas Sethi sir and Sibarama Panigrahi sir. And I hope this pre-conference tutorial, you people will learn a lot from stewards of computer science and engineer from NIT Rourkela and IGIT Saram. They are going to give you a brief on three important topic of today's world or industry 4.0, whatever you say, or about your career, what you are going to do. As a computer science engineer, days were there when we are feeling of, writing a program is the best skill to get a job. Now writing a program, everybody can able to do. But knowing much more than that, the three keywords of computer science today is machine learning, IoT, and big data. One is giving you all about algorithms, how you can able to analyze and get the insights. That is what we call it as a machine learning. A machine can learn it, but as a human is always have some input. The input can be gathered with sensors. That is what we call it in a computer as a IoT. That is Internet of Things, which will take different inputs, different sensors, and it will give you the detail about the data. Is we talk about here is a big data, because we know that every day we are generating, you know, petabytes. I can say it's a very small amount in today's time. So we are generating, or as a single human being, we are generating some terabytes of data. Okay, so this conference and this pre-conference tutorial, I hope will give you a insight like what is the data analytics and all about what is an IoT and what is big data, what is machine learning. I hope these three key terms at least you can able to get it, and I hope your image, your attitude will reflect what is the IIT to the external guest. So please maintain the decorum as a professional. Don't behave like a kid of standard. You are already in the sixth semester. You are about to appear the campus drive. So be careful and behave as a student of the IIT. Thank you, everyone.
Thank you, sir. Amongst us, we have our respected Dr. A.B. Srinivas Rao, sir, Dean School of Engineering and Technology, GIET University. He has contributed many years of his life for research in robotics. During his tenure as principal, he had introduced multiple methods to improve the academics, research, and administration. A highly motivated person, his positive mindset reflects on his actions. I kindly request, sir, to please come forth and address the audience. Please, sir.
Respected dignitaries on the dais, Deputy Dean, Computation Sciences, professors of Computer Science Department, other faculty members, my dear budding engineers, very good morning to all of you. So, actually, we are very fortunate to have such a refresher course before the actual conference. To just I'll recap what is there in your mind. So we are nowadays where a welcome drink is given with artificial lemon, and at the end, after finishing the lunch or a dinner, a finger bomb is given with a natural lemon. It is order of the day. So when you exercise by going to the gym, you move to build muscle. Am I right or wrong? So you against the gravity. That means only will get a muscle. If you just lift it, you will not get your muscle. That means to build, you have to take the pain. Without you cannot get any gain. So no pain, no gain. So try to concentrate on these 2 days most effectively. Try to concentrate on what the professors who came all the way from all the corners of the country has come and would like to enlighten you in our university. Try to concentrate on that. Try to get at 10% of what they say. Try to practice. This is a very good opportunity. The Department of Computer Science, School of Engineering, GIET University. I wish you all the best. Thank you. Thank you and all.
Thank you, sir, for sharing the insights. I would like to call upon Dr. Sibarama Panigrahi, sir, who is presently working as an assistant professor in Department of Computer Science Engineering, NIT Rourkela, Odisha. He is a senior member of ICMIB and presently working as an part of developing crude oil price forecasting methodologies, employing methods and models of deep learning through his project sponsored by SERB, Government of India. He has published more than 40 research papers in the reputed journals and conference. His research interests include swarm and revolutionary algorithms, machine learning, and forecasting. Recently, he has also developed and deployed an electrical load forecasting software employing deep learning models for predicting the electricity load of Western Odisha. I would like to request to please come upon and further and address the gathering. Please, sir.
Thank you for the nice introduction. Dignitaries on the dais, respected faculty members, and my dear students. So, this conference, ICMIB 2024, is covering the state of the art techniques and technologies that are required to be learned by an engineer. So you see, the IoT, through IoT, we will get large amount of data. So the big data comes into the picture. Now, by getting only the big data, what you will do if you can't get insight out of those data? So in order to get the insights out of the big data, you have to use machine learning and nowadays the deep learning models to explore the data and to get insights out of the data. So I hope your time is pretty much valuable, especially the students' time is very much important to us, and you will gain so much things that will help you in shaping your career in future. You might go to become an engineer where also you are going to use these techniques, or you might become a researcher or a PhD scholar where you will learn in this conference or before this conference, this tutorial talk, you will learn, get to know the methodologies, and in conference you will see how to present the papers, how to write the papers, how to publish in conferences and journals. You will have a glimpse of that, right? Which will encourage you to do research in near future. So with this short speech, let me conclude. Thank you.
Thank you, sir. Now I would like to call upon Professor Srinivas Sethi, convener, Indira Gandhi Institute of Technology, Sarang. Professor Srinivas Sethi is professor in computer science, engineering and application and has been actively involved in teaching and research since 1997. An excellent scholar in his field. He is member of editorial board for different journal and program committee, member for different international conferences and workshops. He is book editor of 4 international conference proceedings published in Springer and Taylor and Francis. He has published more than 80 research papers in international journals and conference proceedings. Now I request to please come forth and share some insights. Please, sir.
Good morning, all of you. Respected dignitary on the dais, and my beloved faculty members, staff members over the year. Respected Professor Murli, respected Professor Srinivas, respected from NIT Rourkela Professor the Sibarama Panigrahi. I hope this event is very joyful for this audience. Those are interested to work with the data science, machine learning, IoT, they can enjoy a lot from Professor Panigrahi, who explained the time series forecasting using optimized deep learning and hybrid models. Nowadays, is a very essential part of this research work. Uh, you cannot ignore that in this era because IoT is coming to picture. 5G, after getting the 5G ready, lot of sensor can be accommodated in a particular small area. So within a small area, lot of data can be generated, and that can be treated as a structured data, maybe unstructured data, maybe semi-structured data. So analyze all the things, big data analysis, and you can analyze all the big data through the machine learnings. So these are the integrated part of the research activities nowadays. Highly applicable in the real time applications. It is one kind of real time, real life applications. Nobody can escape this. Nobody can skip this in the real time, in the real life. In the general life also, you have lot of data from the birth to death. Lot of data we have. We, it is very difficult to analyze the data manually. To make the efficient way, we can go to these different analytical job like machine learning, time series analysis, deep learning like this. So I hope this session is very enjoyable, and all these audience should take care of all these uh, sessions, and you'll get benefit from this session for your professional lives. Thank you all. Thanks.
Thank you so much, sir. As a token of our appreciation, we would like to present each of our guests with a memento and felicitate them with symbolizing our gratitude and admiration for all what they do. May it serve as a reminder for the profound impact and love you have had on our lives and the lives of others. I would like to request Dr. Professor Kakita Murli sir to felicitate Professor Srinivas Sethi sir, convener at GIET Sarang. Please, sir. Thank you, sir. Now, Dr. Professor A.V. Srinivasan sir to felicitate Sibarama Panigrahi sir, Assistant Professor of NIT Rourkela. Now, request dignitaries to kindly get off the dice to move further into the next event. Thank you to each and
Now I would like to request Professor Dr. Sibarama Panigrahi sir from NIT Rourkela to carry forward with the pre-conference tutorial on the topic time series forecasting using optimized deep learning and hybrid models. Please, sir.
Good morning, everyone. Okay. Go through time series forecasting using optimized deep learning and hybrid models. So looking into the audience, I will go through the introduction of this one also so that you can easily understand all the things. Then I will go through the recent advances in time series forecasting using optimized deep learning models. So I will first start with the introduction and motivation to this. Then forecasting using optimized deep learning models, various methods in optimizing. Then I will go through hybrid time series forecasting methods, that is additive and multiplicative hybrid methods, parallel hybrid methods, and decomposition based hybrid methods. Then I will go through fuzzy time series forecasting. The basics I will go through first. Then I will go through ignoring membership values. How will you do fuzzy time series forecasting using optimized deep learning models? Then considering membership values, how will you go through? So you try to concentrate. I will try my level best so that all the students can understand this concept, right? So time series. So time series is a set of observations of the same variable measured sequentially through time. So the variable is temperature at GIT University, right? So if you will measure the temperature at GIT University today, day after tomorrow, next day, so it will form a time series, temperature time series at GIT University. So now you just imagine in this IoT internet era, which data is not collected through time. Almost all data is collected through time. Now you see, if you want to measure the number of passengers traveling in an, then it will follow the time series. If you rainfall at a particular location, then it will form a rainfall time series, right? If you will measure the ECG signals of a heart, then it is also collected through time. It will form a time series. Similarly, almost all data, the video, what is generated, it is a sequence of frames through time. That is also a time series. So almost all data, what that is gathered through this IoT and internet is a time series in nature, right? So the time series data can be of two types. One is discrete valued, another one is continuous valued. So discrete valued, if the measurements are measured at continuously through time, for example, the ECG signals are measured continuously through time, then that is called as a continuous time series. Whereas if the measurements are measured in discrete intervals, number of passengers traveling in a particular airline. So today, how many passengers are traveling? Then the next day, how many number of passengers are traveling? Next day, how many number of passengers are traveling? So here you see, the measurements are not continuous. It is measured at a discrete instant of time. Then that is called as discrete time series. So a continuous time series can be converted to discrete time series by sampling at regular intervals or by averaging the things. So now I will ask you one thing, whatever that has been computed by a computer cannot be continuous. So you see, you might think that the video is a continuous thing, but it's not. It's a collection of frames where the frames per second, if more than we are getting, if the frames per second is a larger value, then we are thinking that that is a continuous thing. But actually that is not continuous. Similarly, you see the rotating of fan, if you will think that it is a continuous thing, it looks like a plate, but actually there are three blades, right? So in whatever we are computing by using a machine or by using a computer, nothing is continuous. All this, right? So you see the ECG signals, if you are measuring the signal at suppose 10 microsecond, then it looks like a continuous signal, but actually it is a collection of discrete data values. So a continuous time series can be converted to a discrete time series. How will you convert it? By randomly sampling. For example, at 10 second you are taking a value, then 20th second you are taking a value, then 30th second you are taking a value, then you see it will form a time series of an interval of 10 seconds, right? Or what you can do, from 1 to 10 seconds, you take all the values, take the average value. So you will get a single value for the first 10 seconds. Then 11 to 20, you take the average value, you will get a single value for that, right? So like this, you can convert a continuous time series to a discrete time series. Apply all the time series forecasting methods that we will see and to predict the future. Sir, slider. Then slider. Okay. Next one is time series may be crisp valued or it can be fuzzy valued. Crisp valued, the domain is from a real domain. For example, temperature 20 degrees centigrade, 28.5 degrees centigrade, 25.7 degrees centigrade, 10.2 degrees centigrade. So you see, if the values are taken from a real domain, then that is called as your crisp time series. Means what? There is a crisp boundary, means belongingness of an element to a particular set is either 0 or 1. Whereas in fuzzy time series, what we will do, suppose instead of measuring the temperature in real domain, we will partition it into suppose 5 classes. Let's say 0 to 10 degrees centigrade, very cold, 10 to 20 degrees centigrade, cold, 20 to 30 degrees centigrade, normal, 30 to 40 degrees centigrade, hot, 40 to 50 degrees centigrade, very hot. Now, if I will get a temperature, let's say 28.7 degrees centigrade. Now, 28.7 degrees centigrade belong to the normal class, right? Or normal set. So, I will say that normal set, the degree of belongingness is 0.8, right? Then, that particular time series is called as your fuzzy time series. So, a crisp time series can be converted to a fuzzy time series by using fuzzification, and a fuzzy time series can be converted to a crisp time series by using fuzzification. We will go through in detail, you don't worry, okay? So next, before going through time series forecasting, Am I audible?
Yes.
Before going through time series forecasting, let us have an idea regarding the components of time series. So, if you understood what is a time series, it is a set of observations of the same variable, which is measured sequentially through time, right? So, the components are a time series may have these four components. One is trend, seasonal, cyclical, and irregular. Let us go through what is trend. So trend is a pattern in data that shows the movement of the series relatively to higher or lower values over a longer period of time. For example, here you see, here it is a time series where the measurements are denoted year-wise, right? So it is a yearly number of passengers traveling in an airline, right? So now here you see over the longer period of time, there is a gradual increase in the values. So here this time series is having a increasing trend. Can you tell me what other kind of trends we may have? Decreasing trend, or yes or no? So now you see, obviously the number of passengers traveling in an airline will going to increase as we will move forward, right? So it is a example of increasing trend time series. Let us go through an example of, sir, decreasing trend time series. So you see number of child deaths in a particular geographical location. So you know that the hospital facility or the medical facility are going to improve as we will move forward, right? So the number or number of deaths also that is going to reduce over the years. So here you see there is a gradual decrease in the number of deaths over a longer period of time. So this component is called as trend component. So if it is having a increasing or decreasing pattern over a longer period of time, then that is called as trend. Next, let us go through the seasonal component. Okay, before going through the seasonal component, let me tell you how will you treat the trend components. So the trend components, if a time series has trend component, what you can do, you can directly apply a model, machine learning model or statistical model on it to predict the future values. Or what you can do, you can treat the trend component first, then apply the machine learning and deep learning model. Means first remove the trend component, apply a machine learning or deep learning model, then predict the future values, then again add the trend component to it. So this is one possible way. So in that case, how will you remove the trend component? So here you see in the example I have given you a time series 8, 13, 18, 14, 13, 18. You see if I will plot it, it is shown over here, right? So here you can see that clearly it is having a increasing trend. So how will you remove the trend component? You see, if you will do the fast differencing of the time series. Fast differencing of the time series means T2 minus T1. So T2 minus T1 is 13 minus 8, that is 5. T3 minus T2, that is 18 minus 13, that is again 5. So you see, if you will do fast differencing of the series, then that component can be removed from the series. So now, if the trend component you have removed and you have applied a machine learning and deep learning model, then what you will do, after forecasting, you have to again add the trend component because your time series originally has the trend component, right? So how will you add the trend component again? So here you see 8, suppose your forecasted value is 8, then you have to add this 5 value to here, that is the different series value, so that you will get the next value, that is 13. So now you see 13 plus 5, you will again get the original value 18, right? So you have to add the forecasted value with the difference value so that you will get the original time series with trend component. Are you getting? Or yes or no? Okay, very good. So now you see next component is seasonal component. So now I will ask you one question. You please stand up. Mango price in summer is high or low? Low. Mango price in summer. Low. Low. Yes. Mango price in winter. Very good. Please sit down. You please stand up. हाँ मैंगो हाँ ठीक है आप बताइए टेम्परेचर इन डे हाई टेम्परेचर इन नाइट वेरी गुड प्लीज सिट डाउन ये आप खड़े हो जाइए हाँ हाँ आप हाँ हाँ टेम्परेचर इन समर हाई टेम्परेचर इन विंटर very good. So now you see if a time series has the seasonal characteristics means if it is affected by the seasonal things or calendar then that is called as seasonality component. And you see the temperature in daytime is always high whereas the temperature during night time is always low. So it repeats itself. Or yes or no? It repeats itself. So seasonality is what? Seasonality is a predictable pattern that repeats itself, that repeats at a certain frequency. So now you see, if it is a monthly time series, then usually it may have a seasonality component whose length is 12. Are you getting? So you see, if I will take the average temperature in a monthly basis, so you may see that the average temperature in January month remains same in every year, or it may increase by a certain percentage every year with a trend component, right? But it repeats itself. Are you getting? February, lower temperature, March, bit higher, April, more higher, May, more higher, June, May, more higher. Then it may start again decreasing. Yes or no? So this is called as your seasonality pattern. So now what you can do, suppose a time series has a seasonality component, then you can directly fit a machine learning or deep learning model to model the seasonality component. Or what you can do, similar to trend component, first you have to remove the seasonality component. Then you have to model the time series without seasonality component. Then again add the seasonality component to it. Are you getting? So here the important thing is how to model the seasonality component. So the seasonality component can be removed by two ways. The first one is what? By using seasonal differencing. So seasonal differencing, how you have treated the trend component? By using fast differencing. Fast differencing means T2 minus T1, T3 minus T2, T4 minus T3. Like this you have computed the fast difference, right? So removing seasonality by using seasonal difference means what? Suppose you are having a monthly time series. So what you will do? This January month's times temperature, you will subtract from previous January month's temperature. Next, this February month's temperature, you will subtract from previous year February month's temperature. Now you see, this March month's temperature, you will subtract from previous March month's temperature. So what will be subtracted or what will be remained after subtracting? The residual, or yes or no? The residual means it will be the only values which will be obtained after subtracting the similar values in the previous years. Or yes or no? This is one way. The second way is what? The second way is seasonal differencing using seasonal average. Means what? If it is a monthly temperature time series, you will compute the monthly averages. Monthly averages means January month average, February month average, March month average, different December month average, right? Now, if a new value comes, suppose January month value, then you will subtract the January month average from it. So what we will remain with? We are remained with a value which do not have the values that usually occur in the January month. Yes or no? If it is a February month's data, what we will do? We will subtract the February month's average that we have computed previously, so that we will have the value that is subtracted from the February month's average. Is that clear? So in this way, you will remove the seasonality component. Now the question is, sir, we are having a time series which contains a seasonal component. Seasonal component means affected by calendar effects. So it may be weekly, monthly, yearly, or it may be hourly, it may be daily, right? So it is affected by the calendar effect. So what you will do, first you remove the seasonal component by using any of the two methods. Then you apply a machine learning or deep learning or statistical model to forecast the future values. But now you see the forecast contains what? Do not contain the seasonality component. Now what you will do, for the forecast of January month, you have to again add the January month's average to it. For the forecast of February month, again add the average of February month. So what you will get? You will get the residual component plus the seasonality component. Are yes or no? All of you have understood this one? Okay. So next one is cyclical component. So the cyclical component is similar to seasonal component. It repeats itself. The same pattern repeats itself, right? But now here you see what is the difference between seasonal and cyclical. Seasonal means it is calendar effect. Calendar effect means the periodicity value will be as large as 1 year. But if it is beyond 1 year, 1 or 2 years, then we will call it as a cyclic component. So here you see this is a Linux, number of Linux trapped in a forest time series. The seasonality is 10 years. Means after 10 years that particular animal trapped repeats itself. Are you getting? So here it will be termed as a cyclical component instead of a seasonal component. All of you are clear regarding this? Yes or no? Okay. Next one is irregular component. Irregular component are the components which cannot be predicted. Cannot be predicted means what you see? The Ukraine and Russia war. Who has predicted? Nobody can predict 5 years ago. Yes or no? So there are some periodic, aperiodic and sporadic tasks in every event. So we can predict the periodic task which repeats itself. We can even predict the aperiodic task with some accuracy. But sporadic tasks like earthquake and some uncertain values that cannot be predicted, right? So now you see, no matter how efficient your forecasting method is, it can't be 100% accurate. Even though it is 100% accurate for right now, in future it will become inaccurate with some errors. Are you getting? So you please don't worry regarding this error component. There will be some error, but our objective is to reduce the error, right? Next we will go through time series forecasting. Sir, now we have the idea regarding what is a time series. What are the components of time series? Now, what exactly time series forecasting is? Time series forecasting is the process of predicting the future by systematically analyzing the past observations. So now you see, suppose we have observed a time series x1 to xn. If we will predict xn plus h by analyzing x1 to xn, then that is called as time series forecasting. So now you see, every day you are using time series forecasting. आज क्लास होगा या नहीं? मैं कॉलेज नहीं जाऊंगा. Yes. Once returning from the college, whether there will be rain or not. If yes, I will take the umbrella. Otherwise, I will not take the umbrella. While going through this path, whether the traffic will be less or not, or which path I should select so that the traffic will be less, right? So every day we are predicting. Those who are the students like you also predict that whether by going to the software industry I have a better future, or whether going to academics I have a better future. So based on that you predict by analyzing your expertise or by taking the opinions of experts, teachers like us, then you are making a decision. But what if we can do this thing by help of a computer? And such kind of process is called as time series forecasting, right? So here you see, here there is a thing that is called as H. So H is called as forecast horizon. It means what?
if by analyzing x1 to xn, if you will predict xn plus 1, then that is called as one step ahead forecasting. But if h value is more than 1, then that is called as multi-step ahead forecasting. For example, by analyzing x1 to xn, suppose you have predicted xn plus 5, then that is called as 5-step ahead forecasting. So now how will you do multi-step ahead forecasting? We will go through, right? But now can you tell me whether one step ahead forecasting is more important or multi-step ahead forecasting is more important? Multi-step ahead forecasting is more important. But I will ask you another question. Whether one step ahead forecasting is easier or multi-step ahead forecasting is easier? One step. So which will be more accurate? One step will be more accurate than multi-step. Yes or no? Why? Because you see, as the time progresses, the uncertainty also increases. What I will become after 5 years, I don't know. But I can say that after 2 days, I am going to NIT Rourkela, right? So you see, as the horizon increases, the predictability decreases. Are you getting? But if by somehow you can be able to predict the multi-step ahead forecast in a efficient manner, then that is desirable. Are you getting? Okay. So let's go through another thing that is called as forecasting method. So forecasting method is the procedure to predict the future values by systematically analyzing the past values. So the forecasting methods are 3 types. The first one is called as judgmental, that all of us are doing. Yes, by using our past experience on a particular field. अरे एग्जाम में कौन सा क्वेश्चन आएगा? How do you know? By looking at previous year question papers. Yes or no? That also time series forecasting. Are you getting? So you can also define or train a large language model to predict the question paper for the next semester, right? But you need to have the knowledge of natural language processing and time series forecasting, right? So next one is univariate time series forecasting. Univariate time series forecasting means if you want to predict the temperature time series, and if you are only using the temperature time series, past temperature data, then that is called as univariate. Univariate means one. Means if one time series is associated with the forecasting method, then that is called as univariate time series forecasting. And the next one is called as multivariate time series forecasting. Suppose in order to predict the temperature, you have used the temperature time series, humidity time series, and rainfall time series. Then that is called as multivariate time series forecasting method, right? So in this lecture or in today's session, I will mostly go through univariate time series forecasting method. And when univariate time series forecasting methods are useful, when you don't know what are the effector variables that are affecting the prediction series. For example, crude oil price. If you want to predict the crude oil price accurately, what will happen? An importing country like India, you just imagine how much quantity of crude oil is imported by India. So if you can predict the future values of crude oil, then what will happen? Government will make the policy when to buy the crude oil from the exporting countries. So now you just imagine, you know that you have forecasted that on July 5th, the price will be at its low. So what you will do, today you make the policy, we are going to purchase this quantity, this much number of barrels of crude oil on July 5th. So on July 5th, the price will be less, so you have to pay low, right? And for that, I have got a project from SCRB, Government of India, to predict the crude oil price by using time series forecasting, right? So similarly, I will go through many application of time series forecasting also. So all of you are clear regarding judgmental, univariate and multivariate? Are yes or no? Okay. Next, we will go through a forecasting model. Click on the A forecasting model is a tool to reveal the relationship existing between the past and future data. So now you see, forecasting method can be judgmental, univariate or multivariate. But forecasting model can be a statistical model or a machine learning or deep learning model, right? So you can use the statistical and machine learning models for both univariate as well as multivariate forecasting, right? So all of you are clear regarding forecasting model and forecasting method. So these two terms are confusing, right? But these two terms are different to each other, right? Okay. So next we will go through deterministic versus probabilistic forecasting or point versus interval forecasting. So point forecasting means what? If I will ask you, what will be the tomorrow's temperature? बताइए. हाँ. Tomorrow. 40 degrees centigrade. So that is a point forecast. Is that clear? So if you are predicting a single value, then that is called as point forecast. But if I will ask you, what will be the range of temperature for tomorrow? You may say that, sir, minimum value is 37 degrees centigrade, maximum value is 42 degrees centigrade. Then you see that is called as interval forecasting. Are you getting? So now you see, point forecasting is important. In addition to that, interval forecasting is also important to handle uncertainty because the future is uncertain. You see, tomorrow there might be a sudden thunderstorm. So you might have rain, or means that is a sporadic event, let's say. उसको क्या बोलते हैं sir? Yes. So you can't predict them, right? So then the temperature suddenly will go down. So what you will do? Sir, by 95% confidence level, I am telling that the tomorrow's lower limit is 37 degrees centigrade and higher limit is 43 degrees centigrade. But now you see, there are some accuracy measures to measure the accuracy of this point forecast as well as interval forecast. आप क्या बताएंगे? Sir, I will predict a interval that means 100% accurate. What? Tomorrow's temperature, sir, 0 to 60 degrees centigrade. So you see, whatever will be the situation, it will always lie within the range. Yes or no? So the interval range should be small enough and the prediction accuracy should be high enough. Are you getting? I am going to define you some measures or show you some measures. So first, for point forecasting, the measures are mean absolute error, root mean square error, mean square error, symmetric mean absolute percentage error, and mean absolute scaled error. So why I am showing you all these errors, I want to tell you one thing, and you need to know regarding these error matrices. Means when to use which error metric. So now you see, suppose one researcher has published a paper to predict the temperature at a particular city. So what is the range of temperature? Usually 0 to 50 degrees centigrade or minus 10 to 50 degrees centigrade. Or yes or no? But another researcher has predicted the population of a particular country like India. So what is the range? 140 crore? Or yes or no? So it will vary 140 crore, 141 crore, 141.2 crore. Or yes or no? So now suppose you are using root mean square error accuracy measure to evaluate the models. So in temperature time series, the root mean square error, if your model is efficient, the root mean square error will lie between what? 0 to 10, because the range is minus 10 to 50, or yes or no, in temperature time series. Whereas in population time series, what might be the root mean square error? You are having the values 140 crore. So you see, it will be in thousands, yes or no? So how will you compare these two models? You can't compare. Because why? Root mean square error is a scale dependent accuracy measure. Scale dependent means it depends on the scale. Where if you are using a scale independent measure like MASE, mean absolute scale error, then you can compare two models for two different data sets. Are you getting? So here I want to point out one thing. One is scale dependent. Another one is scale free accuracy measure. So if you are using multiple data sets, it's always wiser to use scale free accuracy measures. Next, let us go through interval forecasting. I have told you this one, right? We will predict an interval, lower limit and upper limit for the future value, right? So now you see the probabilistic forecasting accuracy measures are PICP, prediction interval coverage probability. It means what? You see, here you see, all of you please have a look at this point. You see, it is beyond the prediction interval. But you see, all these black points are within the prediction interval. Yes or no? So PICP tells what? PICP tells how many percentage of prediction values are lying within the interval, or how many percentage of actual values are lying within the forecast interval. Are you getting? So whether its high value is desirable or low value is desirable. High value is desirable. Why? Because you see, you will say that tomorrow the temperature will lie between 37 to 43 degrees centigrade. But suppose tomorrow's temperature is 35 degrees centigrade. So it doesn't lie. Yes or no? So it means that is a incorrect forecasting. Is that clear? And suppose for 10 days you want to do this forecasting. So how many values are lying within the range? That gives you the accuracy of your forecasting model. Are you getting? But now you say that, sir, what if we will take the range from 0 to 50? So every value will come in the range. Yes or no? So in order to overcome that, we are having a prediction interval normalized average width. So the width of the interval should be small enough, as well as the accuracy, PICP value should be large enough. And in order to combine these two, we are having average coverage error, right? So I hope all of you have got a brief idea regarding what is time series, what is time series forecasting, what is a forecasting model, what is a forecasting method, how to measure the accuracy of point forecast and interval forecast. Next, by knowing this much of background, I will now tell you why you will do time series forecasting. So now you see, if you can accurately predict the crude oil price, you just know how much cost you are going to save for a particular country. If you can predict the stock price, no need to do any job. Are you getting? Sit inside your home. You know that the stock price is going to rise. Invest in that stock. Yes? No, sir. We are more talented. What we will do? I will not invest because my model may have some errors. I may lose, right? What I will do? I will develop a software and I will sell the accounts. Grow up, जो आप use कर रहे हैं. Are you getting? I will sell the accounts. Use my app to invest in the stock market, right? And per user, you will charge 10,000 per month. So you see, you don't have the risk of losing, as well as you will have as many number of users, that much of amount you will collect. Yes. Now you see, retail industry. So you see, in the retail industry, the inventory is fixed. Suppose you are going to a retail store, a smart store like Reliance. Suppose you want to purchase an item, but that item is not available. Then what will happen? Sales will go down, benefits will go down. But now you see, you are having much quantity of an item which is not going to be sold. It means what? It has unnecessarily occupied the inventory. Yes or no? So if you can accurately predict the right product in right quantity that is going to be sold in near future, accordingly you will keep the inventory so that your sales will be maximized and benefits will also be maximized. Are you getting? Now, internet traffic. If you can predict the internet traffic, the internet service providers can provide better service. Electricity price. If you can predict the electricity price, then what will happen? You can implement smart grid. If you can predict the call volumes in a call center, then you can schedule the staff Suppose you know that in the daytime there will be higher volume of calls. So what you will do? Large number of staffs will be scheduled in the daytime and less number of staffs will be scheduled during the night time. Right? Predicting the natural disasters like flood, earthquake will assist what? Will assist human being to get prepared. So you know that Odisha is the topper in managing flood. Are yes or no? Yes. So if you can predict the flood and earthquake more accurately, then you can save lives. And lives means money, right? Next, if you can predict the electricity load, so there will be no power cut. Are you getting? There will be no power cut. You can easily know how much quantity of electricity is required in the next days. So which grid has surplus amount, they will sell it, and which grid has deficit amount, they will purchase it. Is that clear? So there will be a balance between the supply and demand of electricity. If you can predict the rainfall, you can assist almost all sectors, including the farmers, right? If you can predict the air quality index, if you can predict the stream flow of a river, so now you see, all of you have gone to Hirakud Dam. How many of you have gone to Hirakud Dam? Yes. So now you see how much quantity of water that need to be discharged from the dam. That is also very important. If you can predict the stream flow, then accordingly you can manage the water resource. To irrigation, how much quantity of water you are going to supply, to that electricity production, how much quantity of water you are going to supply, and for municipality water, how much quantity of water you are going to supply, right? If you can predict the seed demand, then you see farmers will get the right quantity of right type of seed they need. So which will ultimately increase the economy of our country, right? So similarly, thousands of applications. You see, wherever the data is collected through time, that is a time series, and you can apply this time series forecasting techniques in that. So now the question is, how we will use deep learning. How many of you know deep learning? Raise your hands. Deep learning. How many of you heard the term deep learning? Okay, so to go through that, right? I will go through a bit relating to that. How will you use deep learning in time series forecasting? So you see, suppose you are having a time series x1 to xn. All of you please have a look at here. So you know this x1 to xn is a time series. We want to predict xn plus 1. So how will you predict xn plus 1 by using a deep learning model? So you are not aware regarding deep learning. So I will make it as a black box to you. Okay, so you don't worry. Suppose we have identified that the future value is dependent on past 3 values. So what will be the input? The first 3 values will be the input. What will be the target? The fourth value will be the target. Yes or no? So if we will give x1, x2, x3 as the input, the model will predict what? x4. Now I will shrink the window. I will give x2, x3, x4 as the input. What I expect from the x5. Similarly, if I will slide the window up to xn minus 1, and if I will give xn minus 2, xn minus 1, and xn as input, what I will predict? Xn plus 1. Are yes or no? All of you have understood? Now the question is, how will you predict xn plus 2? Change the input. What will you give in the input? Xn minus 1, xn plus 1. Then what will you get? Sir, you have done multi-step ad forecasting. Yes or no? How will you compute xn plus 3? Same way. So here what we have done repeated one step ahead forecasting. Okay. Repeatedly, we have done one step ahead forecasting by using a deep learning model. Yes or no? So there are various kinds of multi-step ahead forecasting. What I have told you, that is called as recursive multi-step ahead forecasting. Another is called as direct multi-step ahead forecasting. So can you guess what should be the direct multi-step ahead forecasting? X1, X2, X3 will be the input. What will be the target? X5. So now, if I will give X2, X3, X4 as the input, what should be the target? X6. Is that clear? Now, similarly, if I will give Xn minus 2, Xn minus 1, and Xn as input, what will be the output? N plus 2. Yes or no? Or yes or no? So here you see, while computing Xn plus 2, have I computed Xn plus 1? No. I have directly computed Xn plus 2. Yes or no? So this is called as direct multi-step ahead forecasting. So now let's go through the pros and cons. Okay. So recursive multi-step ahead forecasting, there is a problem of correlation of errors. Correlation of errors means, sir, Xn plus 2 calculate करने के लिए you have to compute Xn plus 1. So in Xn plus 1 there will be some errors, and those errors are going to affect while calculating Xn plus 2. Are yes or no? Xn plus 3 will be affected by error for Xn plus 1, Xn plus 2. Yes. So this is called as correlation of errors. Is that clear? But whether that correlation of errors will be there in multi-step ahead forecasting and multi-step direct multi-step ahead forecasting, whether the correlation of error will be there? No. Because why? You see, Xn minus 2, Xn minus 1, and Xn if you are giving, what we are predicting? Xn plus 2 directly. We are not predicting the one step ahead forecasts. Yes or no? So there will be no correlation of errors in direct multi-step ahead forecasting. Is that clear? Next, in recursive model, how many models we have to train? One model, because you see the input is X1, X2, X3 and the target is X4. Input is X2, X3, X4, the target is X5, right? But you see, in direct multi-step ahead forecasting, for two-step ahead forecasting, what should be the input? X1, X2, X3, target will be X5 for two-step ahead. X2, X3, X4, target will be X6. Yes, but for three-step ahead forecasting, X1, X2, X3 will be the input and X5 will be, or X6 will be the target. Are yes or no? So now you see, as the input and target pattern changes for your multi-step ahead forecasting, in direct multi-step ahead forecasting, you have to retrain the model again and again for different step ahead forecastings. So that is the problem in direct multi-step ahead forecasting. And DI recursive hybridizes the recursive multi-step ahead forecasting with direct multi-step ahead forecasting. Then another is called as MIMO, that is called as multiple input, multiple output. Multiple input, multiple output means, here you see, before in the output layer, how many neurons you are having? One. You are predicting a single value. But here, how many values you are going to predict? Two values. So you will predict Xn plus 1 as well as Xn plus 2 simultaneously. Similarly, what you can do, here you can keep k number of neurons in the output layer and you can do k multi-step ahead forecastings directly. Is that clear? And the combination of direct multi-step ahead and MIMO multi-step ahead is DIRMO, right? So for a greater detail, you can refer this paper. I will share the slides with you, right? Next, here, the big question is, what is the big question? Sir, How many number of inputs? Here, how many number of inputs I have kept? 3. So how to know that? How many number of inputs? How many inputs? 1, 2, 3, 4, 5, 6, 7. 7 layers. Sir, how you have kept 7 layers? Why not 6? Why not 10? Why not 20? How to know that? Right? Next. How many number of neurons? Sir, here you have kept 7 neurons. Here you have kept 6 neurons. Here you have kept 5 neurons. So how many number of neurons in each layer? How to know? Then other deep learning hyperparameters like kernel initializer, activation function, learning rate. So all those things, how to know for a particular time series. So the big question is, how many number of inputs? How many number of layers? How many number of neurons in each layer? Which activation function? Which kernel initializer? Which optimizer? What is the batch size? What is the learning rate? So in order to tune these hyperparameters, there are 3 possible ways. 1, you can use a grid search. 2, you can use a Bayesian optimization. Or 3, you can use a swarm and evolutionary algorithm. So in grid search, you see, I will tell you one thing over here. There are 2 kinds of hyperparameters. One is continuous valued hyperparameters. Another one is discrete valued hyperparameters. Continuous valued means learning rate. The value may lie between 0 to 1, any value. 0.001, 0.005, 0.01, 02, 03. So now you see, the possible set of values are infinite. Are yes or no? But you see, activation function, it may be either sigmoid activation function, ReLU activation function, leaky ReLU activation function, or CellU activation function. So out of 4, any one. Are you getting? So here the number of options are limited. That's why that is called as a discrete valued hyperparameter. So you see, as most of you are not aware regarding deep learning, I will tell you just 2 things. One is we have some discrete valued hyperparameters, as well as we have some continuous valued hyperparameters. Whereas grid search is inappropriate to handle continuous valued hyperparameters. And Bayesian optimization is inappropriate to handle discrete valued hyperparameters. Whereas your swarm and evolutionary algorithms can handle both discrete valued as well as continuous valued hyperparameters. Right? All of you are getting? So we will focus on swarm and evolutionary algorithm optimized deep learning models. Sir, break na ba? Na continue kariyo. Break na ba? So take a break for 10 minutes. Okay? Then I will start. Sir. Thank you, sir. आप आए हैं अपना आश्चर्य वो फर्स्ट टाइम इसलिए हाँ सर पानी टिके दिया मत सोचो लग जाने सर इनको डीप लर्निंग ऑप्टिमाइजेशन पढ़ाऊंगा ये स्किप कर दूंगा इसीलिए मैं रुक गया क्योंकि डीप लर्निंग पता नहीं है उनको पता नहीं है ना तो ये abstract way concept को देखा abstract way नहीं बुझू जी हां ଆଉ କିଛି डीप लर्निंग रे डीप दिया दरकार डीप में नहीं जाना है डीप में जाएगा तो बाउंस हो जाएगा पळेबो माने गोटे सुधा पळेबो गोटे पळेबो किछ सुतरा हेलानी हां एटा रखि तान हां ठीक আছে बैठिए ना जैसे घंटे ही जो 1 बजे तक मैं ले जाऊंगा सर।
1 बजे तक नहीं लेना है ना सर आपको।
कितना तक लेना है?
उसका
सेठी
12
सर
बजे तक।
कितने तक मैं लूंगा? पूरा ले जाऊंगा? 1 बजे
सर,
तक ले जाऊंगा?
पूरा नहीं सर को
नहीं,
नहीं सुनना है यार।
ठीक है, मैं कॉन्साइजली इसको स्किप कर देता हूँ। सब कुछ स्किप कर देता हूँ।
12:15 तक ले लीजिए सर।
हाँ ठीक है, इतना तक कर दो।
आप पता है वहाँ पे जाके फोटो भी पता है भेजिए ना सर।
significant inputs for the deep learning model will be determined by analyzing the autocorrelation and partial autocorrelation function of the series, or it can be done by doing RQA, that is recurrence quantification analysis. Then once the number of inputs K is identified for a deep learning model, then the time series will be pre-processed. Pre-processed means first it will be normalized, treatment of trend and seasonal components, as I have told you previously, right? Normalization means what? Scaling the range of time series to a range between 0 to 1 or minus to 1 to 1 is called as normalization. Why normalization is required? So that in deep learning models, the learning will be faster and efficient, right? Next, the time series of length n will be transferred to n minus k patterns is called as normalization. Why normalization is required? So that x1, x2, x3 will be the learning models. The learning will be faster. Then x2, x3, and x4 will be the input. Then the time series of length n will be transferred to n minus k patterns is called as normalization. Why normalization is required? So that x1, x2, x3 will be the learning models and the learning will be faster. K can be anywhere and x4 will be the input. So the time series of length n will be transferred to n minus k patterns is called as normalization. Why normalization is required? So that x1, x2, x3 will be the learning models and the learning will be faster. K can be anywhere and x4 will be the input. So the time series of length n will be transferred to n minus k patterns is called as normalization. Why normalization is required? So that x1, x2, x3 will be the learning models and the